there, math analyzers. So we just finished practicing our discriminant of our roots, right? So what did that really mean, right? So you're talking about, okay, we're plugging these values from our quadratic equations into only the stuff under the radical for b squared minus 4ac, right? In the quadratic formula. What does it mean to know the types of roots? Well, let's review the properties of parabolas. Okay, so let's look at a graphed quadratic function and remind ourselves what the roots really are when we replace that 0 with the y for the function. So we've changed the equation back to the function form, right? What we've really been doing this whole time so far is we have been looking at when y equals 0. Well, that's called the x-axis. So let's take a peek at what all these pieces are. Okay, so here's a graphed quadratic function. The roots are the x-intercepts. Those are where the quadratic function touches or crosses the x-axis. And I say touches or crosses, most of the time it's crossing and continuing to go. But if you have the one real root scenario, that's when it only touches the x-axis and comes back up or continues back down, whatever it may be, right? That's the one root scenario. And that's when that one root is also on your axis of symmetry. It's also your vertex, and it's also your axis of symmetry value for x, okay? All these things connect, right? So if your parabola is like this one and it continues down, this is a smiley face parabola as I like to refer to it, and it continues down and has its vertex way down here, where it crosses in these two spots are its roots. In this case, the roots are -1 and 3, which means if I solve the quadratic equation and y was equal to 0, my solutions would be -1 and 3 for solving the quadratic equation. That is the roots. The other two pieces we haven't discussed yet, but of course you've discussed in the past, are axis of symmetry, and the vertex is on the axis of symmetry. So the vertex is always the point where the x value is the same as the x equals for the axis of symmetry. All right, it's kind of neat how this all goes together. And by the way, the formula for finding the axis of symmetry equation is the front of the quadratic formula when you erase the discriminant as part of it. When you pull the discriminant out, what's left over is the formula to find the axis of symmetry for a quadratic equation that's in standard form. It's kind of neat, right? Kind of neat how all that stuff comes together. So I want to remind you the difference between standard form and vertex form of a quadratic function. Standard form is going to be just like standard form of our quadratic equations, ax squared plus bx plus c equals 0. Now let's replace that 0 with a y, okay? So that's what we're looking at. When you use the standard form of your quadratic equation, this is the axis of symmetry formula. It's, like I said, the front and bottom of the quadratic formula, -b over 2a. If your quadratic function is in vertex form, well, the axis of symmetry is just the opposite sign of what's in here, right? So this is a minus h here. You pull out the positive version, the opposite sign of what's in there. Because the vertex is h comma k in parentheses, and that's this point right here. That's why we call this vertex form. Okay, so standard form, use this for your axis of symmetry. Vertex form, use that opposite sign for your axis of symmetry. Your axis of symmetry is a vertical line, so it's an x equals line, so it is an equation. It's always got to be written as x equals where it touches the x-axis. Okay, it has to be written that way because it is an equation. And so that is something I won't be lenient on at all, because it's not, if you just tell me your axis of symmetry is 3, you are wrong. That's not what an axis of symmetry is. It's a line, so it's got to be an equation. Thankfully, it's always a vertical line, so it's always x equals. So it'll be really easy to figure out. But keep in mind, that is also what the formula is, right? X equals negative b over 2a. So you'll remember that it'll automatically be written in there. But please, God, don't ever tell me that your axis of symmetry is just a number. Okay? I can't acknowledge that. That's not the case. It's always an equation. So, what does this mean for us and the work that we're going to do? Well, it means that we're going to go back and looking at different forms of quadratic functions, we're going to find all this stuff algebraically. Then later, we'll graph these things and match everything up. Okay, that's what we're on at this point in our work with quadratics. So A is, of course, a quadratic function in standard form, and I am asked to find the axis of symmetry. Well, that means if it's in standard form, I use x equals negative b over 2a, which means I don't actually need the c term at all to figure this out. It's still early, guys. I still need my coffee. So negative of negative 6 divided by 2 times 1. Let's see, the negative of negative 6 is positive 6. 2 times 1 is 2. If this can simplify, please do. 6 divided by 2 is, of course, 3. So my axis of symmetry, which, of course, you know, I abbreviate as AOS, is x equals 3. There's our answer. If your quadratic equation is in vertex form, it's even easier. Ready? My axis of symmetry is x equals negative 2. It is the opposite sign of what's inside the parentheses. That's it. Now, finding the turning point, possibly a little bit more complicated if you're in standard form, because what you do is you take that x value that you just got. Remember, our axis of symmetry, I'm just going to rewrite it here, was x equals 3. You take that x value you just got and you substitute it in for x in the equation to find the matching y. And what this gives me is the point where x is 3. It'll give me the y of that point. Okay. Now, of course, we've got our graphing calculator, so we really don't need to worry too much here. We've got 3 squared minus 6 times 3. Sorry, my buttons are so small, it's hard for me to see. I got to arrow back because my minus got missed. Second insert. Let's get a minus. There we go. Okay. And then plus 8. There we go. So our matching y is negative 1. So when I'm asked for the vertex, I'll just do v for vertex, right? But it's got to be in point form, parenthesis, x, comma, y, end parenthesis. That's our answer for the vertex. You could also abbreviate it as TP for turning point, right? You know, that's how this year's going, the whole toilet paper thing. Might as well. Vertex, toilet paper, same difference. However, if your quadratic function is in vertex form, you don't need to do any of that. You don't need to take, we already knew the axis of symmetry for this is x equals negative 2, right? But I don't need to plug that in right here and algebraically solve. It's gonna be this, okay? This value is going to be what y equals if I did that, because this is vertex form, and that's all I need to do is pull the opposite sign of the x term from in here and the correct sign of the y part of the coordinate from back here. That gives me my vertex. All right. Is the vertex a maximum or a minimum? That's where I use the very elementary but very easy to remember smiley face versus frowny face. When you're smiling, you're positive. When you're frowny, you're negative. And your A value determines that. So whatever the coefficient is in front of the x squared determines if you're a smiley face parabola, right side up, or a frowny face parabola, upside down. Smiley face parabolas have a positive x squared term. Frowny face parabolas have a negative x squared term. That's how you can remember it. Nice, easy way to do it. So, when it comes to both of these, I'll just sketch and then let you know, right? Positive x squared, this is a minimum. Negative x squared, this is a maximum. That's how you can determine if your vertex is the top point in a parabola, the maximum point, or the bottom point in a parabola, the minimum point. A parabola can't have both a max and a min. It's one or the other. Because, of course, as we know, this continues on to infinity from here, or this continues on to negative infinity from here. Okay, so it's either the top or the bottom, one or the other. Smiley face parabolas have a bottom. Frowny face parabolas have a top. That's it. Okay? Now, the whole finding the zeros thing is what we have been doing so far. The finding the roots, finding the zeros, finding the x-intercepts, all of that is what we have been doing in chapter 6 so far. Okay, it just means where are we touching or crossing the x-axis, which means you replace y with a 0 and algebraically solve. Okay, factorable, so easy, right? What times what gives me 8 but adds to give me negative 6? That'd be 4 and 2. Of course, both signs are the same and they're both negative because the bigger factor always has to have the same sign as the middle. And then we t-chart. So x minus 4 equals 0, so x equals 4. There's one root. X minus 2 equals 0, so x equals 2. There's the other root. Now, roots are points, so 4, 0 and 2, 0 are the points where that parabola will cross the x-axis. It'll cross at 4, 0 and 2, 0. Okay? That's where that parabola will touch and cross the x-axis. So now you've got a picture of what this parabola looks like. You know its axis of symmetry. You know its vertex. You know if it's smiley face or frowny face. And you know where its roots are. So you've got a good sketch going of what that parabola looks like. Same with over here. Okay? It's still going to be a 0 here. If you want to look at this as far as d-factor it, t-chart, whatever the case may be for your roots, right? If you want to look at it that way, I would suggest putting it in standard form, potentially throwing it into the quadratic formula. But of course, this is squared, so let's just kind of look at what we get here by foiling, right? So you get x squared plus 4x plus 4. And of course, that whole thing is negative. And then you got this minus 1 here. So I just did that FOIL real quick. And now there's the negative out here of that. So you get negative x squared minus 4x minus 4 and then minus 1. So that would give me a negative x squared minus 4x minus 5. Well, why don't I just plug that into quadratic formula real quick? All right, so x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. Because I can't tell if it's factorable right away because of that minus in the front, right? So be careful here. Let's see. Negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 1 times negative 5. Uh-oh, this guy's going to be negative. All divided by 2 times negative 1. So I can already tell based on my discriminant, I'm going to end up with a negative number under the radical. So that means I'm going to get imaginary roots, but let's figure out what they are. So negative 4 squared minus 4 times negative 1 times negative 5. Good thing we plugged it in here because only the quadratic formula or completing the square would have gotten me my irrational, my imaginary roots here. So negative 4 under the radical. You got x equals 4 plus and minus the square root of negative 4 over negative 2. And we know that 4 is a perfect square, but we've got that negative 1 factor. That's your I. So you've got x equals 4 plus and minus 2I over negative 2. So divide both of these. Divide both of these by negative 2. You get negative 2 plus and minus I as your final answer. Those are your roots. Imaginary roots. What that means is this parabola does not touch or cross the x-axis. So this parabola is a frowny face parabola, if this is my x-axis here, right? This parabola is a frowny face parabola, which means it never comes up and actually touches or crosses the x-axis. I'm actually technically on the wrong side because its axis of symmetry is x equals negative 2, but you get the idea. Okay? That's how we figure these things out. Okay? That's how we figure all these things out. And lastly, what we're going to do is graph these to prove that. Okay? So I'll use my graphing calculator right here. Let me just expand it a little bit here so you can see my screen a little bit better. I still can't see my buttons. Fantastic, but that's all right. Press y equals, and then type in x squared minus, oh, hello. Let's go back and do 6x plus 8. Press graph to see it. There it is. We kind of knew a lot of those things, right? Look at the roots, 2, 0, and 4, 0. Look at the vertex. It's 3, negative 1. Look at the axis of symmetry. It's x equals 3. Look at the smiley face nature of the parabola. We knew all that information going in. Now we just need the actual points. So second and graph gets me my actual points. Of course, when I'm on a CE for the graphing calculator, it's both color and when I go to this, I see more points than you see. It's a 10 by 10 grid, so I'm still only going to be able to graph 0, 8 up to 6, 8. So that is what I'm going to write down for my points. Okay, and then let me get my other ones. Of course, this is 3, and these we know to be 0, and this we know to be negative 1 from already doing that work, right? Look at this. Here is your axis of symmetry. Here are your roots. Here is your vertex, right? This is the y-intercept, which we can find by plugging in a 0 value for our x, right? So all those pieces we can see just from the table, and we can find algebraically. And that is the whole point in putting it all together. The graph and the algebra all go in together. All righty, let's graph. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, and root, and vertex, and root, and back up. And now connect. Arrows at the end. Do not extend your parabola. If you extend your parabola past the last points that fit and you do it wrong, I have to mark you wrong. I don't want to mark you wrong for something so silly. Okay? I'm going to use my red pen for all the fun stuff, right? All the fun labeling. So let me first label my equation. Y equals x squared minus 6x plus 8. Now all the rest of the fun labels. So here we've got AOS, axis of symmetry, is x equals 3. Here we've got the vertex, 3, negative 1. Here we've got roots, 2, 0, and 4, 0. And I'll just call that R for both of those, right? And I will label this even though we didn't find it algebraically, just because a lot of times now that we're in Algebra 2, we need to be able to identify this guy too. So this is 0, 8, and this is the y-intercept. There you go. We were supposed to label all those things, right? If there were real roots. I did include the y-intercept, but we labeled the axis of symmetry, the vertex, and the roots if they were real. There we are. all the algebra comes together with the graph. Let's do that for this guy who was in vertex form. So all I do here, go back to y equals. I'm actually going to just shut this graph off. So arrow to the right and press enter on that equal sign. Then arrow down to y2, and this is where we're going to type the next guy in. So negative, front parenthesis, x plus 2, end parenthesis, squared, minus 1. And now press graph to see it, and notice that this is, x equals -2 is our axis of symmetry. Our vertex was -2, -1. We can see our y-intercept there. What's that? -4, 1, 2, 3, 5, -5, 0, -5, right? And you can see it does not touch or cross the x-axis. All right, so this time I'll use red to get my points and graph my parabola, and then I'll use blue to label, right? Since it's red on my screen. So let's do second and graph to get our points. And again, center your points on your graphing calculator around your vertex, even though we know that I'm not going to be able to graph -6, -17. Okay, not going to be able to graph those. I'm only going to be able to graph -5, -10, all the way to 1, -10. So -5, -10, -4, -3, -2, -1, 0, and what, +1? Yep, +1, -10 is where we got to. Okay, we knew this, by the way, as our axis of symmetry already. So we already knew this was our AOS and our vertex, right? And 0, -5 is our y-intercept, right? Because where the x value is 0, the matching y is the y-intercept. And then let's just kind of fill in from there. That's that -2, yep, around there. Perfect. All right. Now let's get that stuff on the graph. So 1, 2, 3, 4, 5, all the way down here. 1, 2, 3, 4, 5. 1, 2, 1. There we go. Axis of symmetry and vertex, y-intercept. No roots, no real roots, only imaginary roots. Does not touch or cross the x-axis. Connect arrows at the last points that can fit. I'm going to label y equals -x plus 2 in parentheses squared minus 1. And now, using my blue, I'll label the pieces I was asked for in the directions. So here's my AOS, or axis of symmetry, which is x equals -2. Here's my vertex, which is -2, -1. Here is my y-intercept, which is 0, -5. And imaginary, there we go. And 2 imaginary roots, because there are no places where this parabola is actually touching and crossing the x-axis. There you have it, my friends, putting together the graph with all the algebra that we have been doing. Okay, that's what we're getting at. That's where we want to be. So depending on the form of your quadratic function, it depends on which of the equations you use to find your axis of symmetry and vertex, right? When you go to find your roots, of course, change them into standard form so you can plug into the quadratic formula if you don't know it to be factorable. Okay, I would go with quadratic formula because we know that always works, right? All right, guys. Good luck. Make sure you're labeling those graphs. Make sure that you're listening to me about the parabolas and where to stop and put your arrows, because they do go on to infinity, but we don't want to pull them onto infinity incorrectly. Okay? Good luck. Let me know what you need. Happy to help you. Have fun, guys.